Hey everybody, I wanted to do a quick practice example of what we can do in order to help us with our cooldown. Also, there are a few extra practice problems here that you can do. It's all optional to help you out. And there's an answer key at the end so you can check your answers. This is not mandatory to do. It is just a way to get some extra practice in. That way you can feel confident with this topic of factoring polynomials with these diagrams as we build into this topic of division. All right, so for this first one, wants us to rewrite the polynomial as a product of linear factors. Key thing here is it's asking for linear factors. So our final answer should have expressions kind of like this linear factor. X minus 7 is linear because its degree is 1. The highest exponent is 1. All right, so some of this has already been filled in for us. I'm going to zoom in a little. That way we can see it better when I write. Our polynomial is this function a of x equals x cubed minus 7x squared minus 16x plus 112. So they already filled in some stuff for you here. Right here, we've got x cubed. Out of this diagonal, we should get this negative 7x squared, the second term in our polynomial. Out of this diagonal, we'll get our third term, which is minus 16x, negative 16x, and then plus 112. That'll come out of our last diagonal, which really is just one box. Since there's only this one square or box here, we can actually fill in that 112 already. All right, we can check some stuff. Look, x cubed came out perfect. 0 minus 7x squared is still negative 7x squared. So the information they filled out is actually correct. Now we just got to figure out, well, what should be the second term of this unknown factor that we're finding? Well, what number times x will equal 0? The only number we can multiply something by to equal 0 is 0. 0 times x is 0. So that works out. Now we can figure out this box. 0 times negative 7 is also 0. So now we just have these two up here. Well, now we need to have some number that adds with 0 to equal negative 16x. So that's what we'll have here. What plus 0 is negative 16x? Pretty simple, is negative 16x. Add something plus 0, it will still be the same. Added nothing to it. All right, so now we can see what number should go here. What times x equals negative 16x? Well, negative 16 is our answer. And if you want to check now, negative 16 times negative 7 should equal 112. Get up a calculator. Negative 16 times negative 7 is what we wanted, 112. So now we have our unknown factor, x squared plus 0 minus 16x. If you want, you could call this 0x, but really we don't even need to write this term. This factor is just x squared minus 16, but I'll leave that 0 there for right now. So far, we've rewritten this function. A of x is going to be equal to x cubed minus 7x squared, so I'll write the standard form. Minus 16x plus 112. And so far, our product of factors is the known factor, x minus 7, times the factor we just found, x squared, 0x. Again, you don't have to write that, but it might help us right now. And then minus 16. All right, so we have it as a product of factors. But the thing is, we want a product of linear factors. When we look at this, This factor right here, x squared plus 0x minus 16, this is not linear. This factor is in fact quadratic because the highest exponent is 2. It's got a degree of 2. All right, so what we need to do then is break this. We need to factor this quadratic into 2 linear factors. We'll keep this factor, x minus 7. That'll still be there. We just need to split this one up into 2 linear factors. Well, a of x still equals x cubed minus 7x squared minus 16x, 112, equal to x minus 7 times 2 linear factors. We don't know what they are yet, but we'll fill that in momentarily. This is what we did last week. We learned how to factor quadratics. So what we can do is set up an area model for this quadratic real quick. We'll use the square tool. And we can start filling in what we need. X squared, 0x, and negative 16. So out of here, we get x squared. Out of this diagonal, we'll get 0x. That's why I think it's helpful to still write that 0x right now. If it's not there, then we just know it could be 0x. And then we have negative 16. So we can fill in the x squared and the negative 16. Right, and now we just need to find our factors up here. So first we need what number times what number is going to equal x squared. Pretty simple, x times x. X times x equals x squared. Now we need some number times another number that will equal negative 16. We have a few options. Maybe I'll guess first, 8 and 2. I'll decide which one I want to be negative in a minute, but I know 8 times 2 is 16. One of them will have to be negative to make the answer negative. So then we'll have 8x and 2x. You could probably already see that my guess was wrong. 8x minus 2x is 6x. Negative 2x plus 8x if I flip the signs. Or sorry, if I made this one negative, 2x minus 8x is negative 6x. I don't get a possible answer on this, regardless of which one's negative. It doesn't fit. So 8 and 2 was wrong. Probably starting to see that the correct choice should be 4 and negative 4. Negative 4 times x is negative 4x. And x times 4 is 4x. So now we have something that works. 4x minus 4x gives us the 0x that we needed. So now we have our 2 linear factors. X minus 4. I'll handwrite them in there. X minus 4 and x plus 4. So now we have succeeded in our goal of writing this polynomial as a product of all linear factors. X minus 7, x minus 4 times x plus 4 is our factored form. And we're done. You can check our answer on the fifth frame, x minus 7, x minus 4, and x plus 4. The remaining examples are yours to try. B of x is somewhat completed for you. C of x slightly as well. D of x is a challenge problem. There are some terms missing, so they've given you a hint, and they've given you 2 factors. My hint at that is use one of them at first Once you've used one of them, you're going to have to repeat the process with your new unknown factor using the second known factor. All right, hope you guys have fun with this if you want to try it. Otherwise, I will see you all when I see you. Take care.